Okay. For those of you guys just joining us, I'm looking at the calendar real fast. I just updated it this morning. So, yeah, you guys had nothing due you had nothing due Friday because you took the test Thursday, unless you missed the test. There are a couple of you that I needed to talk to. But otherwise, you didn't have any weird me needing to update your Google Classroom and mess everything up because I hadn't gotten Chapter 3 started anyway. So the nice thing is now Chapter 3 is in your Google Calendar with us starting 3.1 today. Why is there nothing on Wednesday? Alec, focus. Why is there nothing on Wednesday? Oh, the PSAT. Yeah. How many of us are not going to be taking the PSAT because we're not a sophomore or junior? Every sophomore and every junior is taking it. Yeah, we're good. Okay, so. Yeah, there's no option.
2019.
Okay. He can just not come to school. I mean, I guess that's a choice. But he won't be in class, so it doesn't really matter. Anyway, coming back. Well, technically, you always have a choice. Just sometimes it's very unhealthy to choose against what's supposed to be done. So Wednesday there's nothing because I'm not going to do anything without you. There have been years in the past where I've had seniors in here and we've gone ahead and you guys have had to watch the video, but no, I'm just not doing anything Wednesday. We have section 3.1 that's taking a day, so that homework is due tomorrow. Then we have a couple days on the next one, so the next homework's not due until Friday, which is nice. And then I think every section after that is probably every 2 days or so. Our next test won't be until I think the next Monday. Okay, we'll figure it out. If I can squeeze it into Friday, that would be preferred because we're behind. But if it's not going to work out, then I'll go ahead and make it probably Tuesday and spread things a little bit. But we'll do what we can, okay? For right now, though, it's on that Monday, and we'll see whether I get to squish it into Friday or push it until Tuesday. Or shorten it and have it Monday. I don't know. We'll see. But for right now, we're going into Chapter 3. And Chapter 3 is all about puzzles.
Yay!
See, you say yay until I show you what the actual title is of Chapter 3. And you guys, some of you already saw it, and you were saying boo. It's exponential and logarithmic.
Oh, no. Boo!
But really, it's just about puzzles.
Isn't that what we're doing in this Leon?
I'm just doing imaginary rotten tomato.
If you're doing things like doubling and half-life in Mrs. Leon, then yes, you're using exponential and logarithmic.
Oh,
But if you're not doing doubling and half-life, I'm not totally sure you are.
I was thinking of scientific notation.
Growth and decay? Oh, yeah, okay.
Like the 10 to the...
Yeah, you do a little bit, I guess. That's true.
Is
KJ, put up the picture in Spanish.
But, exponential...
Oh,
Careful. What I mean by exponential is, you having something to the x.
Oh, okay.
To the x power. Exponential functions are ones where, and remember, we can do function notation. F of x.
Okay.
Where the x is in the exponent alone. And then if I talk about logarithmic,
Oh, yes.
not milk. Blue milk.
that's kind of ish it. Anyway, yeah, we got logarithmic things and we got exponential things. Exponential. There should not be a T right there. We'll see it. Okay. What I need you guys to remember all chapter though is that you're looking for patterns, and I'm going to be showing you patterns, and then you're going to be using the patterns legally to solve. Question: how fun is a game or a puzzle if you don't know the rules?
Not fun.
Very fun.
I mean,
It is? Okay.
for me, it's
I've had multiple ones of you this year in this class and in other classes be like, ready?
Oh, no.
Whether or not they like math, whether or not they've done well in math, if they're bored, they're chilling in my room, they're like, how does this work? Why?
Because they've done a little.
What's the fun of it if you're just moving pegs?
But then you're not playing them.
Yay. Not like that though, right?
What is the point of the game?
It's like
What's the
checkers.
fun of the game if you don't know what the point is?
There's no fun.
Right?
That depends on the game.
You have no motive.
If you can't win, what's the point? Now, okay,
I
that's
don't either
horrible
way.
advice. If I
I
play
don't win either way,
basketball,
so like.
it's true, right? If you don't know how to win, or you don't know how to do well, or you don't know how to improve, or you don't know how to do better, you're just going out there and just kind of like, no one knows what they're doing, and you just have like these things in front of you, you're like, I don't know. So if there's a volleyball net on the floor, and if there's a ball over here, and if there's like knee pads, you're like, If you don't know what you're doing, where's it the fun? Like, you have to get the net set up, and you have to go ahead and figure out teams and figure out how to play, right? So, chapter 3. Well, for those of you who don't know how to play my game, and you're ever bored in here. Those of you that do know how to play,
I was never born here.
you're never bored here.
Absolutely.
Last period would significantly disagree. They don't like math, or they don't like me, or they don't like my room. I don't know. We're having issues this year. But for you guys,
They have me doing this.
how does it play? I don't know. It'll turn on. How do you play?
It's like checkers.
It's like checkers, kind of. You hop, and when you hop, what happens to that guy? There you go. And what's the goal?
To have one left.
To get one left. You get down to 2, well, maybe you're semi-smart. Get down to 3, well, you're kind of, anyway. You should get the Cracker Barrel one that tells you, like, based on how many are left, where your personality or your skill level or whatever. They like to have fun with that.
The size of your brain.
But, well, there's different ones, and they all say different stuff. If you have, well, actually, you guys
Big,
know,
small, medium.
getting down to 1 is the second hardest thing to do.
What's the first hardest?
I forget what the number is. But there is a goal that's like ultra genius, and I only learned this a couple years ago. If you get down to, is it 9 left?
What?
8 left? There's a number on the other end of the spectrum that's even harder to get down to than 1. Like, you have to get stuck in 9 places, 8 places.
Isn't that repetitive?
I could probably
Something
figure
like
out
that.
how to do that.
No, it's like it's kind of easy to get down to like 4 or 5, but it's hard to get stuck with like
Oh,
no
okay.
moves possible with like I think 8 or 9.
Oh yeah, that's hard.
Yeah, no, it's
Yeah.
crazy. I don't know what the number is though. You should Google it. Anyway, coming back.
Yeah.
Some of you have already beaten that down to 1. You're like, oh, that's easy. Go looking for the 8 or 9. But chapter 3, exponential, logarithmic. Here's the deal. We have to learn the rules so we can play. What are we playing at most of the time? Solving for x, usually. That's usually the point. We're trying to break pieces down. But if you don't know the rules, you can't play, or you're just going to be doing illegal things all over the place and just getting me probably calling you on it, being like, no, not like, or the book calling you on like, nope, that's not right. And it gets really frustrating if you keep on playing wrong, right? Or if you keep on losing, like that sucks. So we have to learn the rules, we have to learn them really well, we have to practice them really well, so that way we can basically solve the puzzles. But we're starting off easy, exponential functions and their graphs. We're going to have a couple sections on exponentials, a couple sections on logarithmic, and then we're going to put it all together. We're working up to having equations with nasty expressions that we know how to deal with no matter how they throw them at us. So, exponential, here we go. Last chapter, we were talking about
We're talking about polynomials.
we're doing transcendental functions.
What?
You're welcome. We're transcending.
That's a big word.
Welcome.
Air transcendental, no.
Whoa, is that a
I feel like I just want to go algebraic. Why did I forget the entire category of
Last
polynomials and
chapter.
rational functions?
Me too.
Video email.
Probably true.
Oh, I was right. Go team. I do kind of know my stuff. It was algebraic. I thought that was too easy of an answer. Algebraic functions, those polynomial dudes, those rational dudes. Oh, the dudes that normal pre-cal have a test on Thursday. You get some tutoring algebra. But these ones are called transcendental functions. They're not the only transcendental, but we are transcending. How are we transcending? Well, one way you can think about it, even though that's not at all what it means. Guys, where is the x going?
in the top?
There you go.
It's floating.
It's transcending.
Like the axe movie in Bible class.
I have just a right.
I want to agree, and yet I really don't. So
It was
I
last
don't know how
year.
to
You
answer.
guys remember that?
Oh my god.
So my exponent is transcending.
There it is.
Axe one.
Yeah.
Someone got it.
He's just flying. The animation was so bad. It was so
At
good.
least he has the idea of rising. Okay, so base.
See, big brain time.
Well, it's not totally bad though, because Jesus' ascension, I guess we could almost say
Who's the animation?
Jesus X. That's what we're calling it from now on.
let's not. That's a little weird. But A is the base. Okay, to be honest, I usually do B to the X. Because it doesn't really matter what letter is down there, because all you need to know is that these bases have to be constants. Look on the board. What do I have as the base of the exponential function?
2.
Got him. It's a number.
Big
It's a
brain.
constant, right? So those bases are constants in exponential functions. The bases are constants, whereas the variable is in the exponent. Variables go in the exponent, or variable expressions, and then constants are in the bases. Now, I want you guys to grab out your calculator really quickly and prove to me that you know how to do exponents in said graphing calculator. Poor little algebra kids had to do exponents when we were doing exponential, just basic ones. Well, because they didn't buy calculators even though they're supposed to have them. They borrow mine, but everyone up there is different, and so it's hard to find it. But you guys all have TI graphers, and all of them are similar in that. How do you get an exponent?
Probably happened during the mosh.
The little caret button, right?
During the mosh.
Yeah. JJ was assaulting
When
me.
you hit the inequality.
I did it like last Colin did really good.
That actually was. He's actually like a good dancer.
Wait, Alex, did you dance? Alex. Oh, Alex, yeah, Alex, you're good. Okay.
You were just on the equal sign. There's an app you can turn on that kind of messes it up, but you don't have that turned on. So for letter A, what are you supposed to be doing if it says, there's the function, find the value? When?
You plug it in.
Yeah, because what they mean by value is find the f of x. What they mean by value is find the f of x. Okay, so letter A.
Wait.
How do you get f of negative 3.1, which is 2 to the power of negative 3.1? What button are you using?
Plug it in.
The caret. Gracias. You're using that one, yeah?
Gracias.
No sé. What are you guys getting? Something big, right? Like 8-ish?
Let me see.
Oh, it's a negative number. Duh. It's negative power. So negative 8-ish.
No, 1 over, right? No, wait, yeah.
A, it's not negative, and B, it's not 8-ish. Instead, it's 1 over 8-ish, because remember how a negative exponent just flips the expression in the denominator? So it'd be, if you want to, 1 over 8-ish. If you want to do 1 divided by 8, it's 1 over 8-ish, because 2 cubed is 8. But, okay, what are you guys getting as your actual decimal?
0.1166.
298.
That's great.
Need 3 dots. There you go. Is that good? But if you were rounding like we've kind of been rounding ever since the pre-cal graphing calculator handbook, unless the book says otherwise, we would stop at 3 decimal places. Boop, boop, boop. Got him. Wait, so that's weird. I wonder what would happen if we plugged in higher and higher and higher numbers to this one.
Get out of here. Stop.
Letter B.
What happens if Ken stays in Ken?
Letter B. Not too bad, right, guys? You do f of pi. Pi is just a constant, no big deal. So 2 to the negative
So-
pi. I can plug that into my calculator. What's that going to be?
1 over.
Yeah, 1 over 2 to the pi. Remember, pi is just a number.
I hope Pi Day is our school day.
Friday is my mom's birthday, so I hope it's done on school
May
day.
14th? Or, March 14th?
Why am I going to say 1 over 8-ish again, but a little bit smaller? Why is he just a little bit smaller than that guy?
Because it's a small.
3.14150. So it's just a little bit higher and a little bit bigger denominator means a little bit smaller number. So we get 0.113. 113?
Yeah.
When you round it? Perfect. We all know how to use our calculator to put the little caret in.
Yeah.
Can you go ahead and go to your y1? Can you graph 2 to the x and then graph 2 to the negative x? Because even though these answers are very much the same, guys, one was a negative number and one was a positive number. So these functions, these graphs must be behaving quite differently.
The negative.
And when you graph them, I want you to find their x and y intercepts, please. When you graph them, I want you to find their x and y intercepts.
Oh, that's key.
So y1 is A, y2 is B.
What's like an X?
1.
Correct. Hey, look at this mini parabola.
y1 is A, y2 is B. It's not a parabola. I mean, if you put the two together, but
Yeah.
careful, remember, they're two separate things, right?
1.
Mm-hmm.
What's true about their y-intercept?
They're both at 1.
They're both at 1. They should intersect there, right?
Mm-hmm.
What's true about both of their x-intercepts?
Oh, I forgot.
They're like right on the thingy.
Is it? Asymptotes.
Yeah. Alec, I liked how you started. You said they don't, and then you tried to like make it work, right? But I like that they don't, because they don't. They don't what?
I don't want to cross it.
Never touch.
They never cross it. They never touch it because, Emily, what's the?
No touch.
Yeah, horizontal asymptotes. So therefore, if I was to graph this guy, is letter A growing or is he decaying? Is he going up or is he going down?
Down.
Letter A?
Oh,
I think he's growing. Is he growing?
growing.
Now, if I plugged in a negative number, it was really, really tiny. If I was to go over here to negative 3-ish, yeah, he's like basically, he's not at 0. He's just really, really close.
They never really touch it. Then I go to like some scientific notation type deal.
Yeah, no, exactly. Right? Because it'd be times 10 to the negative, making it small.
Don't talk to me.
Or same thing here, Alec, even if I went big, it's going to get times 10 to the positive, something really big, so it's going really high. And what's different about the second guy?
He was the opposite.
Yeah, he's not growing, instead he's
shrinking.
decaying is the snazzy term for it. He's decaying, because if I were to come over here to 3-ish, which is high-ish, right? He'd be really low, getting lower.
Decaying like my brain.
Which to some degree, eventually, since he's approaching 0, like, he gets so close that it doesn't really matter. But anyway, that's okay. So we have our 2 to the negative x, which is swooping down. We have our 2 to the positive x, which is swooping up. Can you guys change those bases to be whatever the heck you want, as long as it's a constant? Go. But whatever you change one, change the other. Make them still like the same as far as what one base is the other is. Change it to be whatever base you want.
I'm gonna do 500.
Any constant.
I'm gonna do 1.
I'm gonna do 69.
I broke it.
You did break it.
Woo.
Wait, why did Emily just break her swoop? Because everyone else should be getting a swoop. Why did Emily break the swoop by putting in a 1?
1's exponent is always 1.
Explain it, but I agree.
You broke it. Emily.
Wait, what's Sophia mean by 1's exponent is always 1? It's not, because it could be 1 to the 10, 1 to the 20, 1 to the 100, 1 to the... It's 1 to the x and 1 to the negative x still. Yeah, 1 to any exponent is 1, right? So, y equals 1 is a flat line. Emily, is it a flat line?
Yeah.
Yeah, well, that's kind of sad.
So they can do any number.
No, but that's the point. So exponential functions, any number? Nope, 1's not allowed. Can anybody think of the other number that's not allowed?
What about negative 1?
0 is not allowed. Because 0 to any exponent would be 0, right?
Yes.
So it's going to be a flat line, but it's 0. You won't even see it. It's on the x-axis.
Negative 1 doesn't work.
So 0 doesn't work. 1 doesn't work. Wait a minute. Emily broke it again because she... Well, hold on. Let's talk about the ones that work, and then we'll go back. She's
Stop
breaking
breaking
all over the
math,
place.
Emily.
Who got a swoop? Who got a swoop that looks similar? Okay, Sophia, what'd you put in? 500 for both. Cassie, what'd you put in? 91. What'd you put in, Priyanka? 5. What'd you put in, Caitlin?
9,721,870.
Creativity. I love it.
Okay.
Did anybody put in a fraction just for the heck of it? Like fractions are gross. I wonder if it works.
I put 420.
Nobody?
Not a fraction.
Okay, Sophia put in a fraction. Meanwhile, Emily, how'd you break it again?
Stop breaking math!
I put a negative 1.
Okay, everyone go put in a negative value.
Oh, get out of here.
Why is it so funny to me?
You keep breaking math. It's not. You're breaking the But she just gonna fly in here and he's gonna be mad.
No, hold
Mr.
on.
J is too overwhelmed with his rich kids at
Oh, Christian.
Yeah. We're gone.
So y equals 1 to the x.
It's a fraction. Stop. What are you doing?
It's a factorial.
Y equals 0 to the x.
Imagine negative 0.
Y equals negative 1 to the x.
Oh, you guys.
We'll talk about y in just a second. Who else put a negative number in a base and still got a swoop, but it was reflected down? Anybody still get a swoop, but it's like down
That's
instead
like a
of
meniscus.
up? Reflected across the x-axis. Did it reflect? Oh no. Cassie, what are you looking at? Hold on, I'm curious.
I zoomed out and it disappeared, and I'm seeing it.
Oh, now you're trying to get it back. Yeah. That's what
Stinky.
Ruby. Hi. This is the one when he runs for president.
Huh?
I'm
There's
just
this
gonna
one
put the 4.
where it's like the presidential like the presidential debate, and like it's just in there. It just says Le Monkey.
Okay, coming back. Here's my question. Some of you guys, when you put in negative numbers as bases, they were broken just like Emily's.
Just like my hopes and dreams.
But why did Cassie's still get a swoop?
There's more ways to break it.
Well, hold on. What's the difference between some of you guys that it was broken and Cassie's, which was not?
Let's take the other one. The thing.
She actually did like negative 400,000 something.
Oh, okay.
But I'm just trying to make it smaller so that we can see it. Why was hers fine? Wait, why is hers flipped down?
I have a question.
It's not a negative base. It's a reflection. What's the difference between this one and this one? This one is a negative base.
Because the parentheses.
And this one is a reflection. Shh, focus. So the negative base,
That was good.
the parentheses. Sophia's trying to tell us back there. The parentheses say who is the negative base in this one, or who is the base? Negative 1. And that's what you did, right? Emily, that broke it?
Yeah.
Okay. So if anybody else put in a negative 1/4, or a negative 50, or a negative 100, or a negative 13, or a negative 42, or a negative anything, right, Alex? As a base in parentheses, it's going to be broken. But why is this one okay? PEMDAS would tell me, now guys, careful, my algebra kids, they all screwed up on this. PEMDAS would tell me what's being raised to the x power. 4 is being, PEMDAS tells me if it's written like that, 4 is what's being raised to the x power, and then 4 to the 1, 4 to the 2, 4 to the 3, what's happening after 4 is raised to a power? PEMDAS, exponent, and then, who is this guy? It's technically negative 1 times. So, Emily said, let's put the negative number into the base. Cassie said, let's reflect the positive number. So it's really hard because when you put it in your calculator, if you don't know exactly what's going on, you might not know exactly what the calculator is giving you. If you put that in and you meant negative 4 to the x, it's not going to give you the right answer. But in this one, this actually does work. If you have a negative times an exponential function, it'll just be a reflection down. But if you have a negative in an exponential function, why didn't it work?
Because they're boomers.
Well, what's negative 1 to the 0?
0. Wait, this one.
Anything to the 0 power is?
0.
No!
It's
Your
one.
calculator-
One.
Oh, gosh. Guys, you're killing me. Okay. So anything to the 0 power is 1. It's okay. We're reviewing exponential functions. Anything to the 0 power is 1. Okay, what's negative 1 to the 1? Negative 1. What's negative 1 to the 2? Positive 1. What's negative 1 to the 3? Oh, stink. Can it ever make up its mind?
No.
What's it going to be doing forever?
Schizophrenia.
Bouncing back and forth and never approaching, converging to one
The
value.
sound wave type deal.
Kind of. You're thinking like trig functions, not yet, but kind of. But it is bouncing back and it is oscillating like that. So, all negative numbers will be bouncing, they'll never be swooping. So therefore, no, all negative numbers. Well, hold on, Sophia, you tried fractions. What happens when you try a fraction? What fraction did you try? Did it still swoop?
Yeah, but it's
Yeah. How was it different? Was it growing or was it decaying?
positive one went the opposite way. Yeah, the positive one,
Went this way?
the positive one decayed.
Yeah. And then what did the negative ones do?
It increased.
Yeah.
Or grew.
Like this, right?
Ish.
It's
I don't know. You describe.
Well, what I'm thinking of is if you raise 4/5 to positive numbers, the fraction will get smaller and smaller and smaller.
it looks like the
If you
same
raise it
as
to negative numbers.
it's the same as the normal graph, it's just wider. Like instead of getting smaller, it
That
just
too,
gets
but
bigger.
it's the opposite thing.
What do you mean it's the opposite?
Whereas the positive one is the positive.
It's the exact same as those graphs except for it's just wider.
Yeah, that's better.
Oh, got it. I didn't show both of them. Yeah.
Yeah.
I didn't show both of them.
I didn't choose
But if I
those.
was just showing this one, yeah, because this was the negative. Sorry, Sophia, I forgot I had to do both of them. But if I'm just showing the positive one, then it would just be that swoop. Okay, so hold on. From this, what can we say? Exponential functions. Is it any constant in the base? Yes or no?
Yeah. No.
Mm-mm.
Yes.
Emily, you broke it 3 times. Well, twice, but I added the 3rd time. When? Oh dear.
She played math.
What can the bases not equal?
She slayed it.
0.
Bases cannot be 0 or 1 or negative. Wait, is that actually, that's so messy. Like that's just, but didn't we just try it out? Fractions are fine, positive fractions are fine. Reflections are fine as long as the bases are positive numbers. Everything is fine except, is that really true? Exponential functions. Exponential functions. Whenever we're talking about f of x equals a to the x. Whenever we're talking about f of x equals a to the x, exponential functions are only for the bases that are greater than 0 and not equal to 1. Does that make sense?
Just say greater than 1.
No, because what about 1/2 or 4/5 and all those other ones? Yeah. That's a struggle. But are negatives allowed? No. And is 1 allowed? No. So there are exceptions. Exponential functions, the base can be any constant that, any positive constant. Oh, you know what? I could put this so much simpler. Couldn't I say that a must be any positive constant other than 1? I know, but technically gets the idea across. So when I say greater than 0, it has to be a positive base. But like Cassie showed us, there can be a negative in the very front, like negative times, like a reflection, but not inside the base. So the base can be any positive constant other than 1, or any positive non-1.
What's monotone?
Think about the word monotone.
Like in like black and white?
That's monochromic, right?
Similar. Similar.
It's just a setting on the iPhone. It's like monotone. It's like it's a black and white filter.
Similar. Hang on to that. I was thinking monotone as in someone's like voice intonation. See, if someone's monotone. If a teacher's monotone.
Mr. Hampton.
He is
He has inflection in his voice. Domain.
Mr. Hampton.
Those are the X's, right?
H_Carmichael.
Oh wait, let's get the basic graph up here. So if we have a positive number down here that hasn't been reflected and is not a fraction like 4/5 and has a positive exponent, it'll always be going through the point 0, 1. And it'll always be swooping up. Now I put a lot of ifs in that. I don't know if you guys caught it. I put a lot of ifs. Okay, there's no negative in front, there's no negative up with the x, and it's not one of those crazy fraction ones that kind of flips it a little bit. But most, bless you, most a to the x's, where a is greater than 0 and equal to 1, bless you, are growth equations, exponential growth equations, with a horizontal asymptote at the y equals 0. They'll get closer and closer and closer, but never hitting, like you guys already said. and increasing to infinity. So, how far left and how far right? Forever to forever, negative infinity to infinity. How low does it go? That's the range question.
It can't be 0.
Can't be 0. So
Greater than
closer
0.
and closer. In interval notation, that'd be 0 to infinity, right? But yeah, we could go ahead and do a little like x is all real numbers and y is greater than 0. We could do that.
Y-intercept.
Why didn't I put x-intercept?
Because it never touches the x-axis.
Got him. And then the y-intercept is going to be 0, 1, and we'll see y in just a... Hold on. What did I say just a second ago about any base to the 0 power?
It's going to be 1.
Oh, that's why they're all going to cross through the exact same point on the y-axis. Except, did anybody try 0 to the 0? Oh, that's right. 0 was an illegal base anyway. Maybe
It's
not
illegal.
everything to the 0 power is 1.
What?
Strictly monotonic. Strictly, what does that mean?
Like,
Must.
Kind of like only. Must, yeah, must be. Must be
so
only doing what?
One.
like it's the dilly thingy though, right? The swoop dude. It's always gonna look like that.
Hey, what does a parabola do as far as increasing, decreasing, constant? Do you remember?
Increases at the
It increases at the bottom of the vertex or after the bottom of the vertex, and what does it do before?
decrease.
So decrease, increase. How about a cubic function?
Increase with
It
increase.
could
Oh,
increase,
inflection.
decrease, increase, right? It could change. It could have like an inflection point. What about one of those W quartic guys? What does it do? Yeah, decrease, increase, decrease, increase. But what does this do?
It never has an inflection point.
Never has an inflection point because it never changes concavity and it never changes at all. I mean, it does change. It gets steeper and steeper and steeper and steeper. Ooh, that's calculus. Or less and less and less steep. That's calculus too. But coming back, does it ever change from increasing to decreasing?
No.
Like one graph, one swoop. Nope. Guess what strictly monotonic means?
Never swoops.
It's strictly either increasing or decreasing. This one's increasing, but we saw decreasing ones, right? It's possible. Sophia's 4/5, something less than 1. If you have it on a graph, it's going to be decreasing.
So like in this case, 1 is kind of like 0 when like it changes from like going up to going down. Never mind, that was a small range. Thank you for reinforcing my stupidity.
Yes.
Of course.
If you have a base that's bigger than 1, it will be growing. If you have a base that's in those little baby fractions in between, it will be decaying.
See, I'm not stupid.
Is that what you're thinking? Like
Yeah.
1's the separator? Yeah.
I didn't say you're stupid, I said you have a small brain.
Horizontal asymptote.
I agree.
Emily, you already
Put the
broke
shovel
math.
down. Put the shovel down. Okay, what's HA?
You broke my spirit.
Where is it at? Oh. Got it.
Broke my self-esteem.
What? Isn't the horizontal asymptote at the x-axis, which is y equals 0?
Yes.
And then it's continuous, just like polynomials, in that there are no like weird vertical asymptotes, no weird holes like rational functions can have. No weird breaks like those steppy functions. Remember the steppy functions at the parking garage? The piecewise functions. This guy's going to be nice and smooth. He just can't go beyond that horizontal asymptote, or he won't go beyond that horizontal asymptote, and he only goes up or only goes down, and he has a nice little swoop to him. Can we plug in a couple things real fast? Sure. What if I was to, because tables are like the way that we explore with functions we're not super used to. What if I was to plug in something like -2, -1, 0, 1, and 2? That's super basic from algebra 1, right? What would happen if we plugged in to this function, a to the x, let's plug in 0. That's easy. Oh, let's just use this guy.
But what's the
We can still answer at 0 though, because a to the 0, as long as he's not 0, well, anything to the 0 power is
0.
Okay.
Shh.
Which is why a to the 0 is equal to 1. Everybody's going to go to that point 0, 1 as long as he's exponential. Well, even Emily's broken 1, that went through 1. 0. Sorry, 0, 1. 0 to that, that's going to have some major issues. That one's not going to work. Negative numbers would still go through 0, 1. What would happen if I plugged in a to the 1?
A.
Uh-huh. So if A is something like 5, wouldn't that mean that it'd go up from 0, 1? Oh, increasing. But wait a minute, what if A was something like 4/5, like Sophia gave us?
It's going to be 4/5.
It would go down. Oh, hey, we can figure out whether it's going up or down just by plugging in. True? And then if I plugged in a 2, wouldn't it be A squared, which is just A squared? And if A was something like 5, 5 squared is 25. Wow, it's swooping up. And if A was something like 4/5, Sophia, help me out. What's 4/5 squared?
I got this.
But what would that be as a decimal, just for point of reference? Be a little bit more than half.
0.64.
0.64. Okay. But wait, where's 0.64 going to fall from 0.8, which is 4/5? Down.
Yeet.
So whenever you have that number, like Alex said, the 1 is the separator. Anything bigger than 1 is going to grow as you raise it to powers, and anything less than 1, but careful, must be a positive. Anything less than 1 is going to shrink. Hence the growing for the 1's greater than 1, and the decaying for 1's less than 1. What's with this negative 1 thing? Why is it getting small on that side if it's getting big on that side? What's A to the negative 1?
A negative
1 over A.
1 over A. Oh, and if A is 5, yeah, it's going to get huge as I raise into big powers, but if I start putting 1 over 5, that's 0.2. Of course he's going to go down. And it's going to get even worse as I do bigger and bigger negative numbers, because A to the negative 2 is 1 over A squared. 1 over 25 is way tinier than 1 over 5.
C.
But what happens if you were to take the 4/5 example and flip him? Oh, now that's going to grow because it's a little bit above 1. What if I was to take 4/5 and raise it to the negative 2? That'd be 25/16. You would flip the 16 25ths. And what's 25/16? Let's divide the other way. 1.4-ish? 1.3-ish? 25 divided by 16. What do you got, Cassie?
1.56.
Oh, 1.56.
Yeah, G.
1.56. Still, it's growing. It's going to grow kind of slower. Oh, wait. Sophia, or Alex, didn't you say the 4/5 was like spread out?
Yeah.
Why? Well, because it was 1, and then 5/4 is 1.2, and then 1.56 is just kind of going slow, right? Anyway, exponential basics. We can transform exponential functions. Yeah, we can. We can do vertical shifts just like we could before. We can change. Oh, that should not be an apostrophe S. There's no possessive. Sorry. There we go. We can change the base. Let's see. Bases. How do those work? Greater than 1, I'm going to grow, and less than 1, I'm going to decay. Is the snazzy word. You could say shrink. But for bases, greater than 1, you're going to grow, like we've been talking about. Less than 1, you're going to decay. C. You could also have a horizontal shift. And as we already talked about, you can also do a reflection. You could have a negative, but remember what that actually means is negative 1 times, hence why that's a reflection. But we could also have a negative, like you guys saw at the very beginning of notes, up here in the numerator, which, well, that's a negative on the inside. That's going to flip across the y-axis. What was once growing is now going to shrink. We could change it that way too. Oh, the reason being is because this is actually 1 over a to the x. The negative exponent always flips it down.
Wait, what? Oh.
And so if we had tons and tons and tons more time, the only extra thing that we would do is we would take an E. What on earth is that? Well, we would just do an example with E. And E's in your calculator, right? Stink.
She's actually really good at slapjack. I'm not even joking.
Peter, let's play with homework. I'll go ahead and have homework due by the end of the day. No, you guys are playing good. All homework due on Thursday after the PSAT, but you should be able to do most of it tonight. Sound good? Okay, I'll go with the deadline. But this stuff is easy if you remember it, but if you don't, we'll review it tomorrow.